Okay, so this next rule of exponents is the power rule. The power rule is when I have a monomial that has exponents raised to another exponent outside the parentheses. So the idea is the power rule means I'm going to distribute the outer exponent to the inner exponents by multiplying. So let me show you this first example right here, okay? So when you have a monomial raised to a power outside the parentheses, I think of it like distributing. So I'm going to distribute this 2 to all of the powers inside the parentheses. And if you ever have a coefficient or a variable without an exponent, you have to remember that there is a 1 there. Okay, so this is 4 to the first power and x to the third power. So when I distribute the 2, okay, it doesn't go to the 4, it goes to the 1. So 1 times 2 is 2. So it ends up being 4 squared. And then x to the third power, I raise to the second power. So I multiply. 3 times 2 is 6. And then I just clean it up. And what I mean by that is simplify. So I don't want to leave it 4 squared. 4 squared is actually 16. And then x to the 6th, like that. Now, I want to explain where the rule comes from. So if you know what, let me see. If you know what x cubed is, okay, x cubed is x times x times x, correct? Which is just x cubed. So whenever I have something raised to the power, think of this as 4x cubed raised to the second power. That means 4x cubed times 4x cubed. Something times itself 2 times. And then this kind of looks like the product, not kind of, it is the product rule that we practiced the day before. So 4 times 4 is 16, and then the product rule says I add my exponent, so 3 plus 3 is 6. So I end up getting the same result. So that's where the power rule comes from. So let's practice a few examples. Okay, so if I start with number 1, okay, there's not a coefficient here. I mean, technically there is, it's 1, but 1 to the 5th power is just 1. And then x squared raised to the 5th power, 5 times 2 is 10, so it's x to the 10th power. Number 2, I have cd squared raised to the 3rd power, so because c doesn't have an exponent with it, there is actually a 1 there. And the reason why I say that is because when I distribute this 3, it's going to go to the 1 and the 2. So c to the 1 times 3 is 3. And then d squared to the 3rd, 2 times 3 is 6. Number 3, okay, so this only applies to if it's inside the parentheses. So this -4 I'm just going to bring down, okay? And then I'm going to distribute this 3 here. I'm going to distribute it to the m and to the n, but this m has a 1 power. So 3 times 1 is 3, and 4 times 3 is 12, so it's n to the 12th power. And it ends up being just -4, m to the 3rd, n to the 12th. Okay, number 4, I'm going to distribute the 5 to everything inside, all the exponents inside the parentheses. Okay, so this doesn't mean 2 times 5. This is 2 raised to the 1st power and y raised to the 1st power. So 5 times 1 is 5, so it's 2 to the 5th. 2 times 5 is 10, so it's x to the 10th. And 1 times 5 is 5, so it's y to the 5th. And of course, we want to simplify this. We don't want to leave it 2 to the 5th. So 2 to the 5th is 2 times 2 times 2 times 2 times 2. That's 4 times 2 is 8 times 2 is 16. Is 32. X to the 10th, y to the 5th. Okay. Number 5. So I'm going to distribute the 3 to all the powers inside. The power of -3 is +1, so always remember that. 3 times 1 is 3, so this is -3 to the 3rd power, okay? And then 2 times 3 is 6, so this is x to the 6th power. Now, this one we have to be a little bit careful because this is -3 to the 3rd power. not 3 to the third power and then there's a negative in front. So it's negative 3 times negative 3 times negative 3, which ends up being negative 27 x to the 6th. Number 6. Okay, so I'm going to distribute this exponent on the outside of the parentheses to all the exponents inside the parentheses. This 1/2 has an exponent of 1, so the same principle applies. 3 times 1 is 3, so this is 1/2 to the third. And then 3 times 3 is 9, so a to the 9th. 4 times 3 is 12, so b to the 12th. 5 times 3 is 15, so c to the 15th. And of course, I want to clean up this coefficient. So 1/2 times 1/2 is 1/4, and 1/4 times 1/2 is 1/8. So my simplified expression is 1/8 a to the 9th, b to the 12th, c to the 15th. Okay, number 7. I'm going to distribute this 2 to all the powers inside the parentheses. So this negative 2 has a 1 on it. 2 times 1 is 2, so negative 2 squared. 4 times 2 is 8, so a to the 8th. 6 times 2 is 12, so b to the 12th. And then I want to simplify this negative 2 squared. Remember, this is not 2 times 2 and then tack on a negative. This is negative 2 times negative 2, which ends up being positive 4, a to the 8th, b to the 12th. Number 8, okay, I'm going to distribute the 2 to everything, all the powers inside the parentheses. So this negative 5 has a 1 on it. 2 times 1 is 2, so this is negative 5 squared. 3 times 2 is 6, so x to the 6th. 4 times 2 is 8, so y to the 8th. And then I want to simplify this negative 5 squared. So this is negative 5 times negative 5 is positive 25. X to the 6th, y to the 8th. Okay, so this last bit is a mixture of all the rules we've learned so far. So we always start with the power rule, the power rule, which is this one. And then we look to see if there's any product rule. And then we add and subtract any like terms, okay? So we have to follow all 3 steps in that order in order to get an accurate answer. So if I look at number 9, okay, I see the power rule right here because I have the exponent raised to a set of parentheses. And then I see the product rule with that dot right there, okay? So order of operations tells me that I need to take care of the power rule first. So that's this set of parentheses right here. So I'm going to distribute this 3 to all the powers inside the parentheses. So 3 times 3 is 9, so it's x to the 9th. 3 times 3 is 9, so it's y to the 9th. And then there's no power rule in this section, but I'm going to bring it down. So it's times xy squared. Now I have the product rule because these 2 monomials are being multiplied. So the product rule tells me that the same base, I add the exponents, okay? So here's x to the 9th and here's x to the 1st. So what I do is I add 9 plus 1 is 10, so it ends up x to the 10th. And then I have y to the 9th y squared, so I add 9 plus 2 is 11, so it's 9 to the 11th. Y to the 11th. And there's your answer. Number 10. I have the product rule right here, and then I have the power rule right here. So order of operations says I need to take care of that power rule first, okay? So this is, I'm going to bring down a to the 3rd because it doesn't apply. And I'm going to distribute this 4 to everything inside the parentheses by multiplying to the exponents. So 2 times 4 is 8, so this is a to the 8th. B has a power of 1, so 4 times 1 is 4, which is b to the 4th. Now I have my product rule. Again, my product rule means my same base, if I'm multiplying, I add my exponents. So this is a, 8 plus 3 is 11. And then there's nothing that I need to do with b to the 4th because there's not another one to multiply. So I just bring it down. So it's a to the 11th, b to the 4th. Okay. Number 11, I have power rule, and then product between them, okay? So I need to take care of both pieces of power before I can multiply. So I'm going to take care of this side first. I'm first going to distribute the 2 to all the powers inside. If I look at it, -2 is raised to the first power, and a is raised to the first power. So 2 times 1 is 2, so this is -2 squared. 1 times 2 is 2, so this is a squared. 2 times 2 is 4, so this is b to the 4th. Okay, so I'm going to leave that like that. On the right side, so we're multiplying this later, I'm going to distribute the 2 to all the powers inside. So this 3 has a 1 power, and this b has a 1 power. So 2 times 1 is 2, so it's 3 squared. 2 times 2 is 4, so it's a to the 4th. 2 times 1 is 2, so b squared. Now, before I continue, I want to go ahead and clean up these coefficients right here. So -2 squared is 4, a squared b to the 4th, times 3 squared is 9, a to the 4th b squared. Okay, now I have my product rule because these two monomials are being multiplied, okay? The product rule says I multiply my coefficients, so 4 times 9 is 36, and then I'm going to add my exponents. So a squared and a to the 4th, 2 plus 4 makes 6, b to the 4th, b squared, 4 plus 2 also makes 6. So there's my final answer. Number 12, I see the power rule, and then I see the product rule again. Okay, so it's like number 11. So I'm going to take care of this side first by first distributing the exponent to all of the exponents on the inside of the parentheses. Remember, this 6 has a power of 1, and this b has a power of 1. So 3 times 1 is 3, so it's 6 cubed. 2 times 3 is 6, so a to the 6th. 1 times 3 is 3, so b to the 3rd. Then on this side, I'm going to distribute the 2 to all of the powers inside. This 1/3 has a power of 1, a has a power of 1, b has a power of 1, and c has a power of 1. So 2 times 1 is 2, so this is 1/3 squared. 1 times 2 is 2, so a squared. 1 times 2 is 2, so b squared. And 1 times 2 is 2, which is c squared. Now, before I perform the product rule, I want to go ahead and clean up these coefficients. You don't want to leave them as with exponents. So 6 cubed is 6 times 6 times 6, which is a big number. 36 times 6. Nope, that's not right. 216. Wow. A to the 6th, b to the 3rd. And then 1/3 squared is 1/9. A squared, b squared, c squared. Okay. Now I can perform the product rule. Product rule says that I can multiply my coefficients, so 216 times 1/9 is, let's see, 2 is 18, 36 is 4, 24. And then what I do is I add my exponents of my bases. So a to the 6th and a squared is a to the 8th. And then b to the 3rd, b squared is 3 plus 2 is 5, so b to the 5th. And this c is the only c left, so c squared gets tacked on. So there's my final answer, okay? All right, last two. Number 13, okay? I see the power rule, I see the product rule, and I see adding, okay? So we're going to take care of the power rule first. So I'm going to distribute this 3 to all of the powers inside. So 2 is raised to the 1 power. 3 times 1 is 3, so this is 2 to the 3rd. 2 times 3 is 6, so this is a to the 6th, okay? I'm going to go ahead and bring down the product rule. So I'm going to bring down everything because it does not apply. It's like when we solve for PEMDAS, we have to just do one step at a time. So we took care of the power rule. I first need to clean up this 2 to the 3rd. So 2 to the 3rd is 2 times 2 times 2, which is 8. Again, I'm going to bring everything down, clean it up. Okay, now we've taken care of the power rule, and now we're going to take care of the product rule, which is this side. So that does not apply to the 8a to the 6. I'm just going to take that over. Product rule says I multiply my coefficients, so 3 times 1 is 3. and I add my exponents. So 4 plus 2 is 6, so this is a to the 6th. Then I have my final step, which is adding and subtracting. I can add here because they have the same last name. They are like terms, a to the 6th, a to the 6th. So now I just read it from left to right. 8 plus 3 is 11, a to the 6th. It keeps the same last name. Okay, number 14, last one. I see the power rule, I see the power rule, I see the product rule, and I see subtraction. Okay, so we're going to first take care of any power rules first. So that's starting with this piece right here. I'm going to distribute the 4 to all of the powers inside the parentheses. This 3 has a 1, and this y has a 1. 4 times 1 is 4, so this is 3 to the 4th. 3 times 4 is 12, so this is x to the 12th. 1 times 4 is 4, so this is y to the 4th. Okay? And then I'm going to move on over. I'm going to bring down this subtraction because it's not a part of the power rule. But then I have the power rule here. So I'm going to distribute this 2 to everything inside. This 7 has a 1 and this y has a 1. So 2 times 1 is 2, so this is 7 squared. 5 times 2 is 10, so this is x to the 10th. 2 times 1 is 2, so this is y squared. This is not the power rule over here, it's the product rule, but I'm going to go ahead and bring it down. So this is x squared, y squared. Okay? So all we've done is take care of the power rule. What I want to do now is just clean up these coefficients. So 3 to the 4th is 3 times 3 times 3 times 3. So that's 3 times 3 is 9, times 3 is 27. 27 times 3 is 81. X to the 12th, y to the 4th, minus 7 squared is 49. X to the 10th, y squared, times xy squared. Okay. Now that I've cleaned up the end of the power rule, we have subtracting and we have the product rule. We have to take care of the product rule of these two monomials before I can take care of that subtracting. So I'm going to bring this piece down, 81 x to the 12th, y to the 4th, minus whatever I get for here. So product rule says I multiply my coefficients and then add my exponents. 49 times 1 is 49. Add my exponents, so 10 plus 2 is 12. Add my exponents on the y's, so 2 plus 2 is 4. Now that I've cleaned up the product rule, I look to see if I can subtract these two. And I can. I know I can because they have the same last name, okay? So now I just read it from left to right. 81 minus 49. I have to apologize, I did not. Okay. Is 32. And then I keep the same last name, so it's 32 x to the 12th, y to the 4th. So it's a mixture of a power rule, product rule, and adding and subtracting. So you have to follow those steps. Just remember the power rule is when you raise a power to a power, you just multiply those exponents.